Hello, everyone. Today, not only is it Renee and I, but we have one of our subscribers, our viewers, here with us to chat about FTL travel, the reality of it. Paul, do you have any questions about FTL travel?
Not at the moment.
We need to get a little more into it, perhaps.
Yeah.
FTL travel is more near term. It's definitely realistic. It's definitely practical. But it's more near term than any one of you out there are aware of. And we have a podcast that we just made about FTL travel. I would advise that you watch that. It's 2 hours. This is packed full of information all the way through. And by the way, all their efforts that we are putting out here in our podcasts and our videos, they're all a part of Project Eos, which is a project to create an interstellar mission to settle Earth humans on an exoplanet, a habitable exoplanet, before the end of the century. Yes, it is doable. We will find one. I'm sure we will. Creating an FTL starship is not so much a matter of engineering, which is of course very important. There are still things we need to work out. We need to get and wrap our heads around the idea and the technology first before we can do any form of engineering. What are we going to engineer if we don't understand the fabric of space and time properly? And that's why we are banging out there the word negative energy and tachyons, because we do understand this very well. Paul, I'd like to ask you, how near term do you think FTL travel is, from your perspective as an outsider?
Well, from my perspective as an outsider and based on all the information that I've been sort of marinating in last year regarding FTL R&D is I think it'll happen within 100 years.
Okay.
And some people think it'll happen sooner, but from what I'm observing, I think it'll be within 100 years.
Now that's interesting, and that's perfect. Why do you think within 100 years and say not within 50 years? Could you, do you mind extrapolating on that, please?
Well, I think it has to do with, I think, well, you have to look at humanity's history from the big picture perspective, and you'll find that sometimes there can be events in certain countries that are like the most powerful countries in the world, and those political events can either give a huge boost to progress in general or give a huge speed bump to progress in general.
Yes.
And we are in a certain time in humanity. We are in a certain chapter in humanity's history where we're at a fork road, and either things are going to explode progress-wise, not just technologically but psychologically, or it's going to go towards the other direction, towards more of a Mad Max type future, and we're sort of at a fork in the road. And I think that because of that, I think that what's most likely going to happen is there's going to be a lot of dark times that's going to happen in the near future.
Okay.
But then if we can get over that hump, that's when we'll begin to experience a new renaissance of technology and culture, general global culture. After that, it's just there's a bunch of stuff that's come to a boiling point. A lot of negative stuff around the world is happening, and it's coming to a head. And I think how fast we get to FTL travel hinges on how well we deal with, how well humanity in general deals with everything when it comes to a head. I hope that makes sense.
Yes, I do understand you. So in other words, we've come to a fork in the road. One way leads to an expanse type future, meaning that combat and
more like one leads to A future where we don't even go into space, or if we do, it's very briefly and is abandoned shortly after.
And the other one is progress.
And in that scenario, because something a lot of people don't realize is that, most people don't realize is that we need to go into space, not just simply to save our species, but to like safeguard it, like by having a backup, so to speak. It's more important than that. We need to go into space in order to actually improve the living conditions here, especially given the circumstances on the planet now. Things like, in space there are different kinds of manufacturing that aren't possible down here. We can mine asteroids or other planets in space to reduce how much we damage our own planet. We can move manufacturing into space. If we don't do any of this, the way the planet's going, at best we'll end up in a kind of dark age, except it'll be harder than the second time around because things like oil and whatnot are already being extracted. All the easily accessed energy and materials have been extracted.
Yes.
Or at worst, well, we don't survive as a species.
Now, that's not just to ground this a little bit, folks, not that we're saying that we're doomed, but what we're saying is that there is handwriting on the wall already in this direction. We have, I would say that, as Paul said, we have come to a Y in the road, but we've actually come to many different Ys in the road. And each Y ultimately adds up to one global Y in the road. And as we can see, even today, certain things are going wrong. I mean, who knew that what was about to happen starting back in 2019? We have a global health issue. But not only that, there's already evidence that the oceans are suffering. We have an ice cap that's threatening to melt, and if it does, sea levels will for sure rise a couple of feet. And in some areas, that means entire cities, entire nations will be underwater, and they need to be relocated to the tune of billions and billions of dollars, or whatever form of currency that may take. So what Paul's referring to is something that a lot of people see, that if we don't carefully consider which direction to take, we could take the wrong one by default, by a reactionary method. And FTL travel, that is, the future of FTL travel, hinges greatly on the direction we take the Y in the road. Again, there's a lot of little Ys, but they all add up to a bigger picture.
Yeah, there is something I'd like to add.
Please.
Yeah, let's just say, if hypothetically speaking, I'm completely wrong in that things are about to get a lot better really quickly, then I can easily see FTL travel happening in 50 years if everything doesn't come to a head and explode.
Yes.
I think 100 years is because it would take nearly 50 years for us to recover from everything coming to a head and exploding. But if that doesn't happen, I think if we just look back and see just how quickly technology has evolved in the last few hundred years.
Oh yeah.
I mean, we went from horse and buggy to putting man on the moon, and that was really, really, really quick. I mean, as soon as we started learning how to fly, things have skyrocketed, and and there's so many breakthroughs happening so much, and that's why I could think that that's why. And we're already starting to experiment with things like antimatter. You know, who knows how quickly things will progress from here.
Yes.
You know, and because like the whole landing humans on the moon, that was just the result of us, you know, working really hard for only 8 years to try to get people on it, you know.
Yeah, about in terms, even if the worst happens, it's not going to take us 50 years to repair. It's not, because the thing is that when you actually look at the resources of the planet and consider likely scenarios, especially if space travel has already begun, which it has, in a larger way, before such a calamity, then we'll actually have the resources necessary to, and the technologies to rebuild much more quickly. For example, after World War II, after World Wars I and II, Germany actually rebuilt fairly quickly because of the resources they had there.
And the will, of course, the will to do so.
The resources were the primary factor.
Yes. If the worst actually took place, what would you consider the worst, Paul?
My personal worst case scenario, I'll say that I'll do the best I can without mentioning political figures' names. But
please don't. Let's not make it political. Thank you.
Okay, well, let me put it this way: is that you know how like history has shown that like one thing that's really repetitive in history is that we'll have like a major superpower that arises out of the world, and it becomes super prosperous, and then it gets to a point where it starts to become parasitic with the rest of the world, and then it sort of falls apart as a result of that. And like Rome, you know, it became one of the best military superpowers in the world for a long time because they didn't just conquer the enemies, but they assimilated any form of military strategy or military technology on top of that. And that was one of the only reasons why they were able to overcome the Spartans. And
actually, that's a little bit, that's a oversimplification.
Yeah, but they
let it finish, please.
But yeah, anyway, but they ended up sort of being a parasite off other nations, and they were like basically pulling resources from other places at the cost of the quality of other places in order to keep Rome, what do you call it, prosperous. And a lot of empires have done that, and over time, it just leads to negative problems to where you'd have one huge superpower prospering at the cost of a whole bunch of other communities around the world. And in a way that's starting to happen here in the United States, you know, where we'll have massive companies that will produce a lot of products, but then they'll sort of outsource their manufacturing and everything to other countries where it's so much cheap that it's borderline slave labor, and that results in less jobs here back at home for us, and it just causes a bunch of turmoil in the economy there with the resources. And I think that if my worst case scenario is that if that leads to United States falling, then that's going to leave a huge power vacuum. And you know, who's going to fill that power vacuum? You know, and that could either become a good thing or a really, really bad thing, depending on who fills up that power vacuum.
I wanted to just to make reference to once more here. Excuse me for interrupting you a second. For everyone to know that the reason why we brought you on and invited you is because we wanted to hear the perspective of someone else. And it's whether your information is absolutely valid, correct, or not is not so much what's important here, but the way you see it. We want to get an overall pulse of the world, you might say, to see what others think about this, so that we can bring about greater awareness. And so, okay, were you done?
Oh yeah, I'm done.
Okay.
That was sort of my perspective on there,
right.
But of within 100 years thing.
Sorry, I felt like I needed to state that. Now, as far as the accuracy of your Rome, you're not entirely. Boy, I'm a little tongue-tied here. You were not entirely correct on Rome, but it's nonetheless, it's your perspective is what we want, and I don't want to try to correct you on Rome unless it pertains to the future. Well, I guess ultimately it does, right? If everyone holds misconceptions or does not see the history or the future in the correct light, then how do we make decisions? How do we make rational decisions for that why in the road that you mentioned? If we don't know what the truth is, if we don't know what the reality of it is, then we're not going to make the right choice. So many people will make decisions based on, oh, well, that person looks like a nice person. I think I'll go with them. I have heard that more than I care to repeat. And that's not an intelligent decision. Our future would be doomed because that's out of balance. The reason why we say that we really don't think that it's going to take 50 years to rebuild, and let's assume the worst case scenario, war, global war. It is in the news, after all. We're not saying anything new here. But let's say that it happens, the exchange turns nuclear, and that means food production will likely drop by 80%, especially if it's in the northern hemisphere. That's a fact we are already aware of. If food production drops by 80%, considering that the majority of food is grown in the northern hemisphere, that's a lot of mouths that are going to go hungry, and that creates an unrest globally. Now, let's say that's the worst case scenario, because anything else is, of course, much better. Space travel, we are heading into space now, and there's the determination to do so. Even corporations are starting to eye up space. The technologies that are employed, the technologies that are being discovered, the technologies otherwise can and will make a difference in the world in helping us to recover. The motion for the effort and motion for space will drive progress here on the planet, unlike any progress has ever taken place before. We are effectively, it looks like we're coming up for an energy crisis, a global energy crisis. You know, what is necessity is the mother of invention. Already on the table, various companies and nations are scrambling for fusion, as we know, as well as other potential power sources. In fact, we did post on our community tab, there's a power source, sonic power source that has not too long ago been proven and can be built. It just needs some engineering and some scaling up and so on and so forth, the usual. Renee, what is your thoughts on that? Because I'd like to hear from you as well.
On what exactly?
On why is it that we can rebuild, say, within 10 to 12 years?
As to why we can rebuild quickly, that depends. If we have a global nuclear war involving every single patch of land, then it's extinction, not rebuilding.
Yes.
But if there's a relatively limited exchange just between, say, the major powers, or less than that even, then, well, there's still the entire rest of the planet that would be untouched, and resources in space. And here's another factor to consider. Mm-hmm. Even in a just like our technology is to the point that we can colonize Mars now. that same technology can be used to rebuild in an irradiated wasteland while we slowly clean it. So as much as it seems like just an end scenario, an analogy is the pandemic. That seemed like something that how would we ever handle that if that ever happened? It's here. We're handling it. It's not the end of the world.
Right. That's right.
Likewise, if the worst did happen, which we hope it doesn't, but if it does, it's not the end of the world. We actually can pull through it. And interestingly enough, in Star Trek, they actually had it where prior to humanity in Star Trek going and building a better future, before they got to that point, there was a nuclear war.
Well, that's right, yeah.
They actually rebuilt out of that. And still managed to do that. That's fiction, of course, but that's just gives an idea.
Yeah, and also, I think it's actually real, that scenario, despite it being science fiction, I see that to be very realistic because it happens all the time, you know, where you'll have someone who's super successful in life, and usually their success starts right after they hit rock bottom. That's a good point.
There's a cycle. Yeah, so there's.
Go ahead. Go ahead, Renee.
Yeah, there's some psychology on that, both on individual level and on a group level.
It gives us the will to strive.
Well, yeah, to quote a favorite movie of mine, Fight Club, you know, it's only when you lose everything that you're free to do anything. And I have a feeling that I wouldn't be surprised at all if everything comes to a head and it all goes to crap, that might actually be the catalyst that we need to actually move forward in a positive manner in a huge scale.
There's another way, and this is paraphrasing a quote someone else has made. Someone else I know may have made.
Okay.
Basically, you can view it like this: either we start to build a more peaceful and humane future, like more like Star Trek, or if we don't, the worst will happen, and in the aftermath of that, we won't really have a choice. The only way out of the only way to rebuild after the worst is to actually start building a better future. So yeah, it's not that it has to happen so much, it's that either we build a better future, start doing that now, and avoid the worst happening, or the worst happens, and then afterwards we're finally motivated enough to do it. The survivors are motivated enough to do it.
Right.
To actually start building a better future. So, again, it's not that it has to happen. It'd be better if it doesn't, but
yeah, it's
a sort of either or. Either we start building a better future on our own as it is right now, or the worst happens and we're forced to build a better future afterwards.
Here's a more optimistic perspective too of what if, is that one thing that I've noticed is that it is so easy to get so distracted by all the negativity that humanity has to offer. But a lot of people tend to forget of how much positivity humanity has to offer as well.
Yeah.
Sure, humanity humanity is equally responsible for keeping a lot of different animal species from going extinct as we are responsible for making species go extinct. And there is a possibility, very optimistic possibility, that nothing will happen and that we'll suddenly move forward. Like there'll suddenly be some breakthroughs, some ideas on how to solve a lot of problems plaguing around the world that fixes a lot of problems. You know, I mean, we already got electric vehicles suddenly becoming mainstream. There's a cryptocurrency company that is investing heavily in nanotechnology that will actually solve the engineering problem in wind turbines that freeze. And it's a certain nanotechnology that solves the problem and keeps it from freezing because they're coating the propellers and the equipment and stuff with this nanotechnology, you know, so that things don't freeze over like all the wind turbines did in Texas last year. Or, no, it wasn't last year, or was it the year before that happened? You guys know what I'm talking about?
I think it was last year.
Yeah. But
it wasn't just wind turbines that froze, it was pipelines.
I wouldn't be surprised that absolutely nothing bad happens and no Third World War happens and we actually just solve our problems and move forward. That's just as equally possible.
Yeah, well, that's definitely a thing that could happen.
Yes.
But being realistic and practical, if you look at the current world situation, that seems unlikely at this point. And also seems a little bit too late.
In other words, what you're saying is that the road signs
just being practical.
The road signs are now posted alongside the road, and therefore the fact that they're already posted, the handwriting is on the wall, I suppose, is a better example. But either way, I think a piece of all of what we're saying, everything ultimately finds a middle ground. So bits and pieces of what we're saying are probably, of each of us are saying, is probably more correct. There is we do have a tenacity. There is a certain amount of effort. We do have the ability to do many great things. And there are a certain number of people, and there is a certain amount of efforts. But so Paul, in that regard, I'd have to agree with what Renee is saying. Is the handwriting on the wall? I agree there as well. I think a certain amount has already transpired, and the fuse has already been lit, so to speak. But it's how we deal with it. What you brought up about problems, when you're at the bottom, you have no place to go but up. When people are secure and comfortable in their cubicle, they don't tend to examine what might be wrong for fear that they're going to lose their comfort. I mean, think about ourselves individually. When we have a comfort zone, we really don't want to step out of that comfort zone. It brings out a lot of fear. But when we do hit bottom, our comfort zone's now gone. Then, and only then, sometimes, we actually throw off the silly comfort zones and ideas that we had before, and we get down, as they say in Texas, brass tacks, and get to work and rebuild, and sometimes rebuild faster. I don't like to say this much, but how many nations are there on Earth that are still around after 5,000 years? None. But each time we rebuild, well, look at today. We have proliferated all around the planet. And 5,000 years ago, we weren't that way. So positives have come out of the falls, yes. But I'd like to shift the conversation, unless you have something more you'd like to add, Paul. I'd like to shift the conversation more towards FTL and what you discovered in your search, your quest to become a starship, engineer?
Yeah. I'm not even sure what to call it. It's just there's I call it. I'm just trying to become a real life version of Scotty or Geordi LaForge from Star Trek. That's been my original dream since I was 2. But most of my life, I've always considered that a pipe dream. I remember around 14, 15 years ago, I actually had a legitimate opportunity to be able to get a full education in aerospace engineering, and I decided against it. It was the worst mistake of my life. And the reason I decided against it is because I started doing my own research. It was right at the time when people were just learning how to use the internet and Google, and people were using Ask Jeeves back then to look up information. And I was looking at how rockets work and everything, and the more I learned about how rocket technology works, the more I realized how much it sucks. And it's like they spend so much money to use it only once, and it's like, this is ridiculous. And it's like people were laughing at me like I was crazy, because I was saying, make these rockets reusable, man. That's why they're so expensive. Everyone thought I was crazy. Everyone was telling me you can't land a broomstick on its end, and I made the horrible mistake of letting these people convince me of that. And as a result, I decided that I didn't respect the what NASA's doing, and I didn't want any part of it. So I decided to not do it. And I decided that starships would never exist in my lifetime because of that stuff. And I had no idea. I didn't have a clue that I was wrong until I discovered SpaceX back about 3 years ago. And I saw a video of them landing a rocket on a drone ship. And I'm like, oh my goodness, I was right. It's like, if I didn't let people convince me that it was impossible to have starships in my lifetime, I would already be working at SpaceX right now. So, and
okay.
And so for like 3 years ago, once I discovered that and discovered SpaceX plans and realized, hey, this can work, you know, they're actually building starships. At this point in my life, I was already a welder for like 13 years, and I fabricated things from river and seaworthy barges all the way to bulldozers for Caterpillar. And it's like, so when I saw his schematics for a starship, I was like, hey, I could build that. And so I started doing, I got on Facebook and I used the power of the internet to track down and talk to aerospace engineers who work for SpaceX. I met a guy who was actually working on the Raptor engines, and I was just getting advice from them on, hey, what do I got to do to get the education experience I need so I could become a starship engineer? Because at that point I realized my very first dream of being a real life version of Geordie LaForge can come true if I work hard enough. So I became obsessed with that. And I found out what the kind of education I needed, what kind of experience I needed to work for SpaceX. So for the last 3 years, not including last year, I paid off $40,000 worth of debt, gave my truck back to the bank, sold my motorcycle, and I did everything I could and every sacrifice I could to get into school as quickly as possible. And
Dedication.
I finally started, and I finally started my first class at Embry-Riddle Aeronautical University, attending the school online, January of last year.
Okay.
And by then, I already have, in a long story short, ended up using the self-taught method to teach myself from basic math all the way to pre-algebra. Then I took an intermediate algebra class at Embry-Riddle Aeronautical University, and by then I already took another math class at technical college because I was trying to figure out if I'm better off attending school online or on campus. And I found in both situations, you're basically paying for the privilege of teaching yourself math. The teacher does not teach you math, and I didn't need tutors because if I was stuck on anything, I would just go to Google or YouTube. And so I realized I was teaching myself. So finally, I got to a point where I was struggling in pre-calculus, and I realized the reason I was struggling in pre-calculus is because when I took the intermediate algebra class, they forced me to skip 3 chapters in the middle of the book and the last 3 chapters at the end of the book. And that, as a result, I couldn't study pre-calculus. And so I was like, you know what? I'm better off teaching myself anyway. And if I teach myself, it's not going to cost me anything versus the hundreds or not thousands of dollars that I'd be paying for school. So I was like, you know what? I need to make my way to Calculus 4 anyway. So I might as well just study myself for free. But right around that time, I discovered your YouTube channel on accident. And because I was thinking in my mind, I was wondering, you know, okay, well, I was convinced that starships would never exist in my lifetime, and now here I am watching these live YouTube feeds of starships being built in Texas. I'm thinking, well, what about warp drive? And so I started Googling that, and then that led me to your YouTube channel and me discovering Dr. Kubier, Dr. Sonny White, Dr. Musha and their work and everything. And I ended up talking to Dr. Kubier over email. I talked to Dr. Sonny White over a Zoom meeting, and I exchanged emails with Dr. Musha. I got information from all 3 of them on exactly what I need to study, because at this point I was realized, okay, I could easily think that warp drive would never exist in my lifetime.
Yes.
But I said that about starships, and it turned out to not be true. So I was thinking, okay, well, now that I'm discovering that warp drive R&D is an actual field of study now, and not just science fiction, perhaps 15 years from now, there might exist a job opportunity for me to be a warp drive engineer. Can I
interrupt you for a second?
Yeah, sure.
Before you jump off, before you go off, because I think this is what you're saying is excellent it shows that something that everyone else needs to hear. Do you think that Musha, Dr. White, and Alcubierre, do you think that, especially White and Musha, and of course there are others, do you think that they see warp drive in our future, or a jump drive?
Well, I've heard from Dr. Sidney White from himself. He believes that warp drive will happen within 100 years. I've never asked Dr. Musha his opinion on that.
I'm pretty sure Musha actually thinks it can be done relatively soon.
But the point that I'm making here is, because of these legitimate scientists who are in prestigious positions, it excited you enough that you have taken and are right now taking the steps to becoming a Scotty, a real-life Star Trek Scotty. You've, like you said, you put in your truck, you paid off $40,000 in debt, etc., etc. You're taking action. You're taking the steps to become a starship engineer before we have a starship. Not because you think that it's not going to happen for 50 years, because something in the back of your mind and in the forward of your mind tells you that it's going to happen sooner than later. Am I correct?
Yeah, because if you told me 15 years ago that we was going to have that humanity was going to be successfully launching and landing a Starship prototype that's 30 feet wide and 160 feet tall in Texas, which is what happened last year. You told me that was going to happen within 15 years. I would have laughed you out the door.
Right.
But now it happens, and it's like, wow. and that led me to that huge mistake of not getting an education in aerospace engineering, because if I did that, I would be working on literal starships in Texas right now. Yes. If I didn't make that mistake. And it's like, now here I am, I'm thinking that there's no way in hell that 15 years from now there'll be a job opportunity for me to be a warp drive engineer. So what I'm doing is I'm learning from my mistake regarding traditional aerospace engineering, and I'm applying it to this. And the way I see it is that the worst that could happen to me, if there turns out to be no job opportunity in the near future for me to be a warp drive engineer, the worst that could happen is I'll end up being a math or physics teacher somewhere. You know. Well, but I'm not even thinking about worst case scenario. I'm thinking I'm just preparing myself, because in my opinion it's going to happen very soon.
Things
at least
are happening.
And I'm just one of many people who have been inspired to get into college for engineering, just because of SpaceX proving to everyone that you can land a rocket and that you can make going to space affordable. And that's just with rocket technology. If we make a breakthrough in MHD technology, that'll be an even bigger game changer. Because right now, it's the bigger focus is just trying to get to space.
Well, that is actually one of the topics that I'm working on, that wingless craft video that we have, the EFE touring. That is a legitimate technology that has already been applied to both aircraft and weaponry, and it's proven itself. And we're applying that to an aerospace craft, which is something that we will be publishing a more updated video relatively soonish. That's a good point you brought up. The moment we can perfect getting into space, what I mean by perfecting getting into space, you can get into your truck and you can go down to the airport and fly to the neighboring state. We've perfected air travel. You can get into a private plane, or you can buy a ticket and get into a small 15-seater jet. When we can do that for space, when we can hop into something that looks like an airplane, that's an aerospace craft, because after all, it does have to go through the air, fly up to the Kármán line, just about 100 kilometers, 62 miles above our heads, and fly around the planet and land back where we started. We've perfected getting into space. Believe it or not, the technology exists for us to do that today. Why it's not done? There's a myriad of reasons as to why no one has done that. But we are making the efforts right now to do just that, to build these aerospace craft. Necessary technology for us to create the interstellar mission to settle a habitable exoplanet. We have to be able to perfect getting into space. We need to build shipyards around Earth, at least 2 of them, maybe 1 on the moon, or 2 on the moon. So, Paul, your thoughts on the technology, from your perspective, from the information that we've provided so far, what are your views on FTL travel? How do you see it? I'm just sort of looking for a broad, your thoughts about it.
Yeah, well, when it comes to getting a good grasp behind when it comes to the science behind, you know, how MHD and other related propulsion technologies would work when it comes to get us to travel faster than light, I feel like that I'm just at the very, very tip of the iceberg, despite me spending nearly a year just collecting as much information as I can, because I spent the majority last year collecting information on it, but now I'm in the next stage where I'm now trying to process and comprehend the information. And like I understand that we would need MHD propulsion for getting into space, and that I understand that we would I understand the basic science of why we would need to be far away from just about everything before we try to jump to light speed due to the wake in space-time. And I understand the need for you know, a deflector dish so that a speck of dust doesn't destroy your ship when you're going at FTL speeds. And I'm understanding a lot of the basic stuff, but as far as the science behind it, I'm barely just starting to scratch the surface and process the information I've collected. And I hope that makes sense.
Yes, it does. I understand what you're saying, and that's exactly what I wanted to hear. I mean, your opinion, because what it tells me is we need to get more information out in a variety of formats. We need to keep haranguing the technology so that everyone can begin to understand what we're talking about and how it can take place. And I think this leads us right over to you, Renee, because you wanted to talk more about the technology.
There is something that I
Paul.
needed to say before we get to that part.
Please do.
There is a problem that a lot of people have, a lot of people like me that have when we're trying to get into FTL R&D type information, is that you got a lot of different groups of people out there that are just as dedicated and excited about this subject as we are. And you got some groups that are real deep into the ufology type community, and they got their own set of information, and they think that they're right, and that their techniques of trying to warp space works. And then you got other people that have their own groups, and it's almost like religious denominations fighting against each other. It's really weird. And it's like I visited a lab not too long ago of a warp drive R&D lab, and the dude swore up and down that he could create a warp field, and then when I showed up, he backtracked and said he wasn't sure if he could create a warp field, and all I saw him do was blow fuses and burn out grounding wires and not really accomplish anything. But he thinks that folks like you who believe more, who are a little bit more heavy into negative energy and tachyons and stuff, that you guys are off the rocker, and that he's right. But it's like he hasn't accomplished anything. All he's doing is he's just repeating other experiments that other people have never been able to get off the ground. And it's like, what's really weird, it's like, because it's just, there's just a lot of confusion out there for people like me, where it's like you run into some group of people and they think, yes, we can make warp drive happen, this is how we think it would work, here's what we think is the real science behind it.
Mm-hmm.
And then you meet another group of people then that they have a completely different set of facts, and they think the other set of facts is wrong, but both groups equally have not successfully created a space warp or a form of field propulsion that they've never been able to get MHD to work. And then it's just so a lot of people like me, what I have to do is I have to sit back and I have to be a neutral attitude and just do the best I can to increase my own knowledge of science, which is what I'm doing right now. I'm working my way to Calculus 4, and after that I plan on fully studying general relativity and then fully studying quantum mechanics.
Excellent.
And then and that way I could have the ability to discern which information to take more seriously, which information not to. And
this is where, if I could say something.
Yeah.
There's actually a simpler approach to that. You don't. While learning that is, of course, definitely helpful and definitely recommend it, you can actually work out what's legitimate, what's not, far more easily.
Oh, okay.
If you think of, you just have to think about it logically about what. First of all, it's a well-known fact that any changes in space-time, any actions that taken and its cause, only propagates at the speed of light normally. If there's a group that says that that's maybe in doubt, that's already a huge red flag. That they are not actually working on anything legitimate. So any changes you do, any attempt to move, it's analogous to the speed of sound. Any bit of air normally only moves at the speed of sound or less. And likewise, with the speed of light, from the point of view of someone who's stationary, which itself is a relative notion, but let's say you have two frames of reference, 2 observers. One moves at near the speed of light, accelerates toward the speed of light relative to the other. So if we say observer A is we'll call them stationary, observer B moving. From observer A's perspective, the ship of observer B going off toward the speed of light, though it maintains a constant thrust, and its acceleration decreases exponentially as it approaches the speed of light. So we say that if its thrust is constant and acceleration is decreasing, its mass must be increasing. And so we see it slowing down and down and down until eventually its accelerations basically come to a halt, and it's now traveling just on the speed of light. From the point of view of the people aboard the ship, though, it's very different. They zoom off, and as they go faster and faster, they actually will eventually see themselves exceeding the speed of light, or appearing to. If they were to measure the relative speed of a dust grain flying past, it would be going faster than light. But once they slow down to a stop, turn around and come home, they find that while to them it's only been like, say, 2 weeks, they've been gone for 20 years. Because what's actually happening is every time you move through space, any motion at all, even just moving across, shuffling your chair around the floor, you're warping space and time. That's what motion effectively is. You're trading space for time and time for space. So keeping that in mind, if you want to travel FTL, there's only one way about it, and that's simply based on the nature of what motion is. If you travel 20 light years out to some point and then 20 light years back. Let's say you're going fast enough so that that this shift in time means that for the crew aboard the ship, the perceived time is only, like, say, a few seconds, or maybe fractions of a second. So what the ship would do is it'd travel out 20 light years. The crew have only experienced, like, say, a nanosecond's worth of time. The ship then jumps back in time by 20 years, plus, like, a few microseconds. Then it turns around, comes back the other way, and does the same thing again. Now, the ship appears to have mere moments after it left is back where it started, and the same amount of time has passed for the people back home as the crew aboard the ship. Are you following so far?
Yeah.
So this is why FTL travel means time travel, because the only way to actually exceed the speed of light is to manipulate time. You can think of it kind of like in a game where if there's a certain speed limit in a game, like say Elite Dangerous, the only way to go past it would be to have to cheat the system a bit. And that's basically what we have to do with FTL. We have to cheat the universe a bit by manipulating time.
Yeah, that kind of makes sense because I mean, space and time. I got like just a basic grasp on the nature of the fabric of space time. What I've learned, space and time go together like peas and carrots, and you really can't mess with one without messing with the other. So I remember actually having a conversation with Todd a while back of that. You know, I was thinking that maybe the technology that you would use to create a warp-capable starship is probably the same technology you would need to create a time machine, because you can't mess with the fabric of space without messing with time. So who knows, you know, what's going to happen with time. I hope that makes sense.
Yes, we understand what you're saying. An FTL drive is a form of time machine.
Yeah, because the only way to actually overcome the light barrier. And also, the only reason why any of us are interested in FTL travel isn't for the sake of it so much. We're not interested in going fast on light for the sake of going fast on light. We're just simply interested in it for the sake of shortening the time barrier.
Yeah.
What I mean by that, it's the same justification with any kind of transportation. We build faster and faster vehicles to reduce how much time it takes to travel a distance. It's the same motivation behind fast and light travel, or like stasis, or using time dilation. The reason why FTL travel in particular we're interested in is not only can it reduce the time experience for the passengers, but it can also make sure that their time and the time experience for the people back home is the same. And that means allows routine interstellar travel.
Yes, the same. That's right.
Now, and so one more thing.
Mm-hmm.
When it comes, you can also view it like this. Rather than traveling some distance and then moving back in time, let's say that every single instant as you were traveling, you were constantly, continually jumping back in time. So let's say for every single second, every microsecond, attosecond, every single time quantum of time that passes, you jump back in time and equivalent to how much you've traveled. So you travel for 1 attosecond, you jump back in time 1 attosecond. And you do it continually so that every time you inch forward a little bit through space, you also jump back in time. And as a result, your ship would effectively exist at the same time along all points along its path. And to both the crew aboard and the people, both any folks back home and at the destination, the ship has just teleported. And in fact, it's a little better than that because the ship is constantly jumping, doing these tiny ultra micro jumps back in time, it effectively exists along its entire travel path for no time at all. And if something exists in a place for no time, for 0 time, then it doesn't really exist there in the first place. So the ship effectively just discontinuously moves from its departure point to arrival point. Just like that.
Hence why we say the ship is dematerialized. It no longer exists in the realm of positive energy, positive matter.
I don't know why that's...
Go ahead.
Oh, I'm sorry to interrupt.
No. We're going to interrupt each other a little bit
okay.
because it's necessary. But please carry on, Paul.
There was this sci-fi show I watched a long time ago called Dark Matter, and they introduced a type of FTL travel technology called a blink drive, and it almost sounds like you guys just described a blink drive. Do you guys know what I'm talking about?
I haven't seen the show, but
it's where instead of like going.
No, I'm familiar with the drive because.
Oh, okay.
In other shows, like Battlestar Galactica, their FTL drive is instantaneous. In the German science fiction series Per Rodan, they also use an instantaneous jump drive. And actually, on the movie and the book Dune, the propulsion system there, the Holtzman drive, is also FTL.
Oh, cool.
Now, effectively, warp drive and hyperdrives are effectively... They work with the same fundamental principle. Both work by distorting spacetime to create a superluminal wave packet. But whereas a warp drive uses positive energy to then give rise... first off, the reason why... this is how you can determine if something's legitimate or not without needing even extensive knowledge. Given like what I just said, you look at the nature of motion, what motion is, what the speed of light means. And the fact that you cannot exceed it by normal means, the only way to actually exceed the speed of light is to go back in time. Does that make sense to you?
Yeah, that makes a lot of sense.
So given that, there's only one way to manipulate time. You can't do it with positive energy. It doesn't matter how much energy and mass you concentrate in a spot. It will never create a backward in time motion. The only way to do it is to set up something where there's negative energy involved. That can be done, as one example, with a spinning singularity in the right circumstance. A so-called ring singularity actually has negative spacetime, opening to negative spacetime within the ring singularity. And that answers the question of which is right, negative energy or not. Negative energy is the only means to actually create a backward in time motion. Now, as to where they get that from, that's another topic. Do you have any thing you want to say in there?
Yeah.
Any questions?
Yeah, one of the hardest lessons I learned last year when I was exposing myself to the whole world of FTL research is that I've learned to not pay close attention to any form of FTL R&D unless they're talking about negative energy or at the very least tachyons. And that stuff seems to... have you ever approached a subject that you're not well educated enough to completely grasp it, but you somehow are able to tell that it's true or false without actually doing the research to know if it's true or false, and then when you do the research then you see that you're right?
Yes.
And it's that's how I am with there's two basic categories of FTL R&D that exist out there. You got those that it's based on negative energy and tachyons, and those that isn't. And those that isn't makes absolutely no sense from my perspective, but even just glancing at stuff that has to do with negative energy or tachyons makes all the sense in the world to me. And it's the more I explore both fields, the more it confirms to me to pay more closer attention to any science out there that talks about FTL, the science of FTL involving negative energy. And what Renee just said explains why. Yes,
exactly. It's you mentioned the various progress that people have, or rather have not made, towards some form of FTL travel or a warp bubble or something like that. We have made progress, and but our progress is not a little spherical warp bubble on the kitchen counter. Our progress is that we can sit down before anyone and discuss and explain in detail how things work, and show them the mathematics, the various research papers that go along with that, and so on and so forth. We can discuss and present and show and back up our claims and back up how things work with intelligence, with knowledge, with experience. So our progress is bound up in that we can, just to restate, our progress is bound up in the fact that we can explain how things work intelligently. And so that's the main That's the huge difference right there.
Yeah, I've noticed that too. I just didn't have the words to describe it, but you just took words out of my mouth that I didn't have.
Well, you're learning, and I have to say, in the time that we have known you and all of our chats, and by the way, for everybody to know, Paul does get private chats with us. And if there are others out there that want to let us know, we can only do a limited number of individuals. But I will have to say, Paul, your knowledge has grown. I can see that you have put thought to things since the very first day we met till today. You have a better grasp on things than perhaps you are even aware of yourself. The other thing you were mentioning about how you don't know something about a subject, but yet the little niggly thought in there, your intuition says, no, I think it's this way. Well, that's what it is. It's intuition. That's a whole nother topic as to what intuition is, and not something I want to go off and discuss now. Okay, so, but why is it that we say that we should have jump ships in 50 to 60 years? They will...
Well, maybe you want to qualify that a little bit.
That's what your task is, if you don't mind.
Hey!
Go ahead.
Well... Okay, first I gotta finish explaining about... Okay. This actually covers some things that I'm going to talk about in the upcoming jump drive video.
Mm-hmm. Okay.
So, the big question is, where do you get negative energy? What's often held up is the Casimir, and that's fine. The Casimir is a simple thing to understand, but there are other ways to interact with the quantum vacuum. Basically, what the quantum vacuum is there's an energy field everywhere around us, consisting of these little particles that affect our forming and annihilating, but it's all happening so quickly they don't even have time to not only do they not even have time to interact with anything else except very indirectly, weakly, but on top of that, they don't even fully have mass exactly. They exist so briefly, they're actually partly negative. So that's part of the answer. Where do you get negative energy?
Okay.
It's already around us everywhere. It's believed that might be responsible for dark energy, for the expansion of the universe.
Mm-hmm. Okay.
A kind of real anti-gravity, repulsive gravity.
Okay.
But there's other ways to interact with it than just a narrow plate. Dr. David Froning and Terence Barrett, they showed that it's actually possible to create more complex, higher order electromagnetic fields and waves, which we've taken to calling null waves and null fields.
Yes.
Because they're formed of how they're formed. That's a topic that's for another time, though.
Yes.
I have to say, basically, they're more... I can explain it like this. Frank Wilczek, in his book Lightness of Being, he talked about, which it sounds like some kind of new age book title, but it was just a clever little title for a book about the weak force and strong force.
Yeah.
Paul, you might actually find that a useful book to read for an overview.
All right.
Well, we'll send you the title of the book later.
And now we can put a link. We can put the title also in the video description.
Yes.
Oh yeah.
So
by the way, I don't know if I told you, Renee, but I got both of Dr. Musha's books.
Okay.
And one of them you can actually find on Amazon.
Ooh.
Yeah.
Perfect.
We can put links to those in too.
Yes.
So, as Frank Wilczek said in his book, the question, it isn't that why is gravity so weak? The better question is, why is matter so low mass? Because there's two ways to think about it, and this is a matter perspective. You can either view it, when you compare, say, a proton and an electron, you could view the proton as more massive, or you could view it that the proton is more complex and intercouples more strongly to space and time, and therefore it interacts with it more. Changing your perspective like that allows you to understand how what I'm about to say is possible. Because you can go and create electromagnetic fields that you can view as, it's kind of like as if you mix the strong force and electromagnetism, or a little bit like the electroweak force.
Yeah.
But not exactly. It's not a merged force, it's a mixed, which I guess is basic electroweak. And what happens is that you might emit the wave, but then it would appear to gain extra mass energy that you didn't give it.
Okay.
Because if you change your perspective from mass energy to instead coupling to space-time, you emit it starts as normal electronic energy in the coils. It's emitted, but as it's emitted, it combines and emits. It's now more complex and interacts more strongly with space and time. And therefore it creates a stronger space-time distortion that we call gravity. And you can also say that the missing energy, quote unquote, is drawn from the quantum vacuum. And so therefore you can emit such light, such null waves all around the ship to tap the quantum vacuum for energy. Musha himself talked about another example of another kind of higher order light, where under certain conditions you can create what's called squeezed light, which has a negative energy. Either way, you emit this around, and you can reduce your effective mass and therefore effectively amplify an acceleration.
Yeah, and to help anyone who's listening to this, a lot of these explanations a year ago I would have not understood one single word of it. But what made the game changer to go from not being able to understand a single word what Renee just said to now to where I understood everything Renee just said is I changed my perspective on light. And you have to ask yourself, what is light? And all light is electromagnetic waves at different frequencies. And that's what it is. And each different light color is a different frequency. Am I wrong about that?
No, in fact, you can go a little further. An electromagnetic wave is simply a detached electromagnetic field. You can see that with a radio wave, with a simple radio. You have a wire, you run current one way through it, and then you reverse the current's direction. If you look at what happens is the magnetic field was oriented one way, suddenly it flips. But that can't happen instantly, so what happens is the old field that was oriented one way detaches and flies off into space. That is all an electromagnetic wave is a detached electromagnetic field.
Which we also call photon. So even a microwave electromagnetic field is a photon.
Yep, microwaves are still photons. Even ELF, extremely low frequency, where the wavelength is a significant fraction of the width of Earth, even that is still photons. And yes, light is just different frequencies. Microwaves are lower frequency than terahertz. Terahertz is lower than far infrared. Far infrared is lower than red light. Red is lower than blue. Blue is lower than UV, etc., all the way up to gamma rays. So yes, you're correct about that.
Yeah, and I think that's great, Paul, that changing your perspective, it opened your mind. And as some people say, well, you don't want your mind so open that your brains fall out. Well, I think that's pretty silly. You always have to keep your mind open. It doesn't mean that you just blindly accept everything just because your mind is open. Changing your perspective that's an excellent point. Quite often, in order for us to see further, in order for us to see outside the box, we need to change our perspective. In order for us to break ground and discover new sciences, new physics, new laws, etc., we need to change a perspective. We need to consider that some of our previous assumptions, or a lot of them, are incorrect, or at least we need to consider that they might be incorrect, and then explore assumptions that we have made before. And in doing so, this is called the scientific method, we will make new discoveries or will confirm the ones that we've already made. Like Einstein's general and special relativity many times have been proven over and over again.
Yeah, so a little bit more about the jump drive then?
Yes, please.
Okay.
So...
And Paul's learning even more now.
Yeah.
Oh, hold on. My cat wants to be let out of the room.
It's great having you on here, Paul.
Oh, thanks, man. I appreciate it. This is...
And
I'm actually... like surprised that I've learned enough to actually have an intelligent conversation with you guys about this stuff.
Well, and you're also getting some, if you don't mind me saying, you're getting some private tutoring too.
Yeah.
That is, who are we to say that we're the ones that have the right information? Well, if anyone who wants to discuss this with us in great detail, then they can find out for themselves. I don't want anyone out there to just automatically take our word for it. No. I've told this to Paul before too. Take what I've said, put it on the back burner, and then go out and discover all this on your own. And when you do, then you'll know. So, Renee, please carry on. Okay.
So, in theory, you could construct a jump drive or a discontinuous drive. By the way, the reason we call it a hyperdrive, the word hyperspace, outside of its popular usage, it's a technical term that simply refers to n plus 3 dimensions. What that means is any space or time or space-time with more than 3 dimensions is a hyperspace. Therefore, the present instant is a hyperspace. The past is a hyperspace. The future is a hyperspace. Space alone, ignoring time, is not a hyperspace. And on top of that, Einstein's equations include a mirror version of the universe, so to speak, a negative space-time. It's not that it's an exact mirror. It's mirror in terms of the energies and the behavior.
Yeah.
And while tachyons appear to be unstable here in positive spacetime, in negative spacetime they're perfectly stable. And you can have a hyperspace consisting of negative plus positive spacetime. This negative spacetime is shown like in a ring warp, as it's called, a kind of spinning black singularity. There is open negative spacetime exposed inside. And the speed of light is is a lower limit within negative spacetime, rather than an upper. And you can also, an old name for a negative spacetime, another name is superspace. So now, a hyperdrive, you could theoretically build one by, if you could generate tachyons at a standstill somehow and emit them in. Or rather, what you'd have to do is you'd have to create a warp field, first of all, by other means, say with EM radiation or specially conditioned, like higher order, more complex EM radiation, like the negative light or squeeze light or the null waves.
Yeah.
And you'd use these to warp space-time to capture tachyons. Because tachyons, they go slower the less energy, the more energy they have. Their behavior is completely backward. The more energy they have, the slower they go, and the greater their momentum. So you would create an ordinary warp field to capture tachyons by giving them energy, and you have to do it quickly because they're going to very swiftly escape again by dumping the energy and accelerating. So you capture quickly you'd build up a bunch of energy and discharge it into a brief pulse of a warp field, capturing tachyons around you, which would then accelerate away. You can control, like say, create a bias by where you capture them. So you can create a tachyon rocket effect. What would happen is a couple things. The main thing that happened is you would create then a tachyonic warp drive, which is completely different from an ordinary warp drive for one simple reason. Normal warp drives are created by positive energy that then is manipulated some way to give rise to negative energy. But this means you're not in full control of it. And it means that you're limited. Going beyond the speed of light requires exponentially more energy. And one problem with the warp drive is that the transition zone, often called the wall or horizon of the warp field, the transition zone forms immense amounts of Hawking radiation, just like a black hole. Mm-hmm. The thinner the transition zone, the wall, the more intense Hawking radiation. That's why White proposed a thicker transition zone. The reason the original Alcubierre drive had the original conception of it has such a thin transition zone was because it was thought at the time that the required kinds of energy, negative energy, could only exist in very small amounts of space. Mm. That's a bit naive because even if it does, it's not that the smallest scales don't exist on larger scales. The small scale is still there at all times. Tiny quarks are still there even though we're interacting on larger scales. Mm-hmm. It's all still there. So it's a little naive to think that you have to have a thin warp field, a thin transition zone to interact with small energies. You could just pulse it really fast or interact it with in another way. Regardless, by thickening the transition zone, you can decrease the intensity of the Hawking radiation. The problem comes is that as you go faster and faster up to and beyond the speed of light, Lorenz Contraction, which is something where basically as you're moving, space and time, from an external perspective, your ship would appear to squash, to contract along the axis of its motion. From aboard the ship, the entire universe appears to contract along its axis of motion. The effect is the same, though. Mm-hmm. The warp field becomes compressed in the forward and backward directions. And so you'd have to compensate even by pumping out more energy or by extending the warp field forward and back. And you have to compensate because the problem is some of this Hawking radiation, the particles have so much total energy, be it mass or kinetic energy, mm-hmm. that they can actually distort space enough to move through the warp field and distort it. They basically create their own gravitational eddies because they have so much energy.
And destabilize the warp field, yes.
At best, weaken the warp field. At worst, completely destabilize it.
Yeah.
So to prevent that, you have to increase the power output and extend the warp field forward and backward. But you can see there's going to be a limit reached. At some point, you won't be able to. It will be impractical to add any more output, any more energy, or to extend it further. So at that point, you can't go any faster. Not to mention, when you stop, all the energy gets dumped in a deadly beam pointing at wherever you were going.
And as a warp drive, you're still can run into debris.
That's another problem because even if you extend the warp field massively, like you extend it thousands of kilometers ahead of you, at the speed you're going, that warp field will be it effectively create a gravitomagnetic field that will whip past extremely rapidly to anything that you run into, which will superheat it. It'll be like something being dropped around a black hole. The tidal forces will crush and warp and superheat it instantly.
You'd leave a trail of disaster.
Well, what would happen is you have a superheated shockwave of gas, just like plowing through an atmosphere, forming around your warp bubble.
Yeah.
You would then, fortunately, it's plasma now, so you can use electromagnetic fields to deflect it. But that's another thing you have to, another limit, because if you're going too fast, you won't be able to deflect in it enough, and your ship will start to be damaged or heated too much.
Yeah, in other words, you start using even more energy, and it becomes to such a extent
that another
becomes
problem.
Impractical. Mm-hmm.
Given that this would be forming a shockwave in front of you and around you, where would you even dump the heat?
Yeah.
You'd have to have radiators extending fairly far behind you and have to have a heat sink. So your travel time is limited because you're soaking up too much heat. You'd have to stop, deploy your radiators, and cool off. And then you'd, once cooled, retract the radiators, start up again. It becomes exponentially difficult.
Conversely, the jump drive solves all of that.
Yeah, so that's how it's different. With a tachyonic warp drive is also a discontinuous drive, and it's fundamentally different from the ordinary warp drive. These tachyons around you, you collect them. You collect them such that they'll emit with a bias as they escape.
Mm-hmm.
Because tachyons go faster the less energy they have, they will actually accelerate the whole warp bubble exponentially quickly. So that your speed will very shortly, within a tiny fraction of a second, be a million times the speed of light.
And hence why it jumps.
Yeah, and also because of tachyons, you'll go back in time equal to how much you're moved. So effectively no time has passed, so you don't really exist anywhere along your travel path. So you can't run into anything. It also means that there's another... hold on, almost done.
Mm-hmm.
I left out something.
Yeah.
The ship, once going fast on light, cannot stay that way without active energy being applied for very long. Because normal, in positive space-time, negative energy tachyons is not stable. So the ship must, within just a tiny fraction of a second, rematerialize. But if you can get going fast enough first, you'll still jump across an enormous distance instantaneously and discontinuously before your ship rematerializes. And so and because of that, advantages are, while you need a very severe a very strong space-time warp,
mm-hmm.
a normal warp drive has to maintain that strong space-time warp continuously.
With positive energy, yes.
Well, it has to do it continuously.
Right.
Whereas a jump drive only has to maintain the warp very briefly. So the total amount of energy required is not that much. It just has to be applied quickly.
I got two questions for you.
Yes.
One, jump drive and tachyonic warp drive, they're both two different terms describing the same thing, right?
Correct.
Oh, okay.
And a tachyonic warp drive is fundamentally different than an ordinary warp drive.
Okay, and in a jump drive, would there still be like a very violent wake in the fabric of space-time?
Well, yes, but it's not going to be a wake in the normal sense. Is that you can think of it, if you could somehow see it, the ship wouldn't appear to jump in a direction, it'd appear to shrink away in all directions to nothing. So the shockwave is mostly omnidirectional.
Spherical, yeah.
And so that disperses energy of a large area. And yes, it's still a very violent shockwave, so it still won't be far from a planet. But the advantage is it's mostly just gravitational, so, and given how weakly matter interacts with gravity, just say like 1 or 2 AU would be enough, most likely to disperse it to harmlessness. Because the shockwave is only created by how you're suddenly existing or you weren't before. And space-time is complaining about the sudden appearance of matter and energy.
Yeah, yeah.
But whereas a warp drive, the shockwave is due to it's accumulated around it over a prolonged flight. Whereas a jump drive, it's just for a brief instant. So the energy release is much, much less.
Is that sort of the same reason why, like, right when like an F-16 is about ready to pass the sound barrier, it looks like there's like this cone of air that briefly appears over the nose? Is that sort of the same principle? You know what I'm talking about?
Yeah, that's a condensation cone. That's due to the sonic boom. And actually, that'll happen even if it doesn't just happen at the transition. It will happen well beyond the speed of sound. It's just normally they're doing that at much higher altitude, far away.
Oh, okay.
Well, there are some videos that show them doing it at just a few feet off the ocean.
Yeah. But yes, it is similar. That's a sonic boom. In this case, it's a gravitational boom. It's a gravitational shockwave, as space-time is complaining about exceeding the speed of light.
So, if you take a region of space-time, which I have to say, I don't think we've actually touched on this even in previous works. Space-time the fabric of space-time is not nothing. It is made up of energy. So,
yeah, I actually mentioned that, and we also talked about it in some earlier videos.
Okay, all right. I just wanted to make sure right now that everyone hears that space-time, when you take an object and you suddenly, that is not there, you take a region of space-time, nothing in it, no objects, and then suddenly you make matter appear within that region of space-time, that region of space-time is going to complain and create a spherical shock wave. So I just wanted to spell that out for everyone listening.
Now, you could in theory do it by just collecting tachyons while you're at a standstill and just teleporting effectively. Thing is that is a bit beyond us. We're not even quite sure how to do that exactly. But there's a different answer. And this is a relativity version, a version described within relativity of Musha's jump drive, which means, yes, it's the start of a unification. Time is quantized, and therefore so is space. It makes sense. Everything else is quantized, why shouldn't time be? Plus, if time is quantized, it kind of explains why everything else is quantized.
Mm-hmm.
And what this means is this. Although the time quantum, which we call it's called a chronon. Although it has a non-zero value, like it's an amount of time greater than 0. Nothing can exist, at least no positive matter or energy can exist for less than 1 chronon. Therefore, it's akin to pixels on your computer screen. The pixel's width is greater than 0, but the computer can't move anything less than 1 pixel. Likewise, you can't move less than 1 chronon into the future, or its equivalent wavelength through space. We can use this. You go up to near speed of light with, say, an ordinary warp field. You then ramp up the warp field so that your mass drops to very nearly 0. Any acceleration or experience will be greatly amplified because suddenly your mass has dropped. This is what Musha talks about with his jump drive. This enormous acceleration means that in less than a chronon's time, your ship is already traveling beyond the speed of light. And because it's interacting over less than a chronon, it has to become a tachyon. Just like how, Paul, you're blowing into your mic, I think.
Oh, sorry. No, I turned around and I guess my mic was facing my fan. Sorry about that.
Yes. No problem.
It's okay. So, just like how the only particles that can exist beyond speed of light is a tachyon. And I won't try to go into explaining that right now. This is already running kind of long.
Yeah, we're at 1.5 hours. Yeah.
But it's enough to just say that just as no tachyons, anything that goes fast speed of light has to be a tachyon. It has to become one if it isn't already. Anything that exists for less than 1 chronon, or moves over less than 1 chronon, becomes a tachyon. And it does mean that, yes, everything effectively oscillates. There's wave-particle duality. For less than a chronon, everything's a wave. Then as the amount of elapsed time approaches that of a chronon, it all collapses to a particle for an instant. Then as that chronon finishes and the next one starts, it expands a wave. That's very oversimplified, but it's a rough analogy. Mm-hmm. So everything turns into tachyons all the time for an extremely short amount of time and then collapses again. Hence wave-particle duality. That's why particles will sometimes act like waves going through a slit and sometimes like particles.
Is that why light sometimes acts as both particles and waves?
Like I just said, yes.
Oh, yes. Oh, okay, yeah. I just made that connection right now. Okay.
Yeah, there you go.
It's the start of unification. There's actually a paper published not last year now, it's 2 years ago already. Yeah. In April of 2020, the title was The Quantum Principle Relativity. And this is a field, and I think that's paper's going to go down in history as the paper that gave this field a name, quantum relativity. This is a new field called quantum relativity. It's been in the works for a while, and it's still largely a grassroots field. And Todd and I are working on our own addition to quantum relativity. We found an equation that appears to describe the time quantum. And I'm still trying to puzzle out and make sense of it, but once that's done, we'll be publishing a paper on that. It's a start of an actual unified field theory.
And it also leads into understanding and therefore explaining the jump drive. Even so more so. Yeah.
What we have is two different explanations for the same thing, which is the key to unification. We have a quantum relativity description of a jump of tunneling via current of the existence of a time quantum, and then we have the quantum mechanical description as Musha has written out. So we have two different explanations two different just mathematical descriptions of the same thing.
Yeah.
But that's the key to then unifying the theories, because if they're explaining the same thing, you know that, oh, this is equivalent to that. Now you have one theory.
Am I correct to understand that, let's just say, hypothetically in the future, that, quantum relativity is out and it's as mainstream as general relativity or quantum mechanics, that at that point people will no longer be going to school to learn general relativity or quantum mechanics. They would all just go to learn quantum relativity.
Yes and no.
Yeah.
It's a modification to relativity.
Hold on. Just like often we still learn and use Newtonian physics because in many cases, for much speeds much slower than that of light, it's a good approximation and it's simpler to work with mathematically. And so we use it as an approximation where we can get away with it. Likewise, quantum relativity, though it covers all cases, special and general relativity and quantum mechanics are good approximations that are easier to work with for most things. So you would still learn general relativity and quantum mechanics, though the curriculum might look a little different, because some things in quantum mechanics are actually easier to understand conceptually with this from the standpoint of quantum relativity. So it might be that, I know we're going to get a lot of angry comments and arguments about this from particle physicists, but in the future it might be that you'll still go to school and learn Newtonian physics, relativity, and quantum relativity, but not quantum mechanics anymore. At least not quantum mechanics as we know it today. You might still use probability waves and probability terms to describe things more conveniently, but you'll learn it via quantum relativity with those as handy tools. Like, it might be that quantum mechanics will not be an independent field in the future, whereas relativity may still be.
Quantum relativity, because
quantum relativity is an extension of relativity, not so much quantum mechanics. It shows that it's basically describing the same things as quantum mechanics from the point of geometry of space-time, rather than just... Because quantum mechanics, again, we're going to get a lot of angry comments and hate for this, but quantum mechanics is effectively just statistics. It doesn't explain why or how. It just explains what, like what's happening.
But quantum relativity can actually do both.
It can be extended at that point, yeah.
Yes,
it's a start.
And one of the key factors to understanding FTL is understanding that time, and therefore all energy, all matter, is quantized, comes in discrete packets. Like Renee said, the pixels on a screen, we'll just call those discrete packets. One of the keys, again, to understanding FTL travel. Actually, for understanding the universe in its entirety. So, do you understand, Paul, when we refer to time being quantized? Have we satisfied your understanding with regards to that? Okay.
Yeah, and but I think that has to do. I think the reason why I'm able to understand that is because of a previous conversation I've had with you when I was when I was asking you what does quantum mean, and then and only then was able to understand that terminology when you applied it the way you just did right now.
Yes.
And I think I don't know. It just seems like what helps me really wrap my comprehension around anything is when I use first principles thinking. You know, where it's like, okay, I find a word in a sentence that someone's using in a subject of science that's way over my head, and I just do research on that one word, and I just like, okay, what does that word mean? You know, and then I go back and it changes your perspective on the whole sentence.
It provides you a level of understanding. So when you read the entirety of the sentence, that one word that you got stuck on, suddenly when you understand that one word, the entire sentence now has meaning to you. That's one of the problems when scientists use too many highfalutin terms to explain things that you can explain in simple basic terms. Now, not to be confused with necessary scientific terms in order to explain what they're talking about. So highfalutin scientific terminology is not the same as necessary terminology. You can't explain everything with everyday language, but you can explain a great deal of it using everyday common language, which is what we try to do so that everyone can start to understand. There's a lot more people out there than yourself, in addition to yourself, that want to learn. We've had numerous people email us saying, you know, what should I study? I want to be involved in a Star Trek-like future. We get a lot of that. So, but again, the quantization of time and energy, first is really the quantization of time. Everything else, energy is quantized because time is quantized. That's the fundamental nature of the universe, one of them. When you look at the pixels of a screen, you think about, you can actually look at the space in between the pixels if you zoomed in. That space between the pixels is negative space. These positive and negative space work together. There's a constant flow, inflow, outflow of negative and positive energy. They work together. They're dynamic. Positive energy cannot exist without negative. If you look
correct me if I'm wrong, but if I understood what Dr. Sonny White was doing regarding an experiment he was doing with Casimir effect, looks like he may have actually found proof of negative energy. Am I misinterpreting that? The thing that I'm referring to? You know what I'm talking about?
Yes, I do. We're familiar with his recent accidental discovery. All that he has done is, in a sense, and not to downplay it because it's still important, White has discovered yet again, because there has been somebody a number of years ago that already discovered that the space between the Casimir plates is indeed actual negative energy, negative space. And White just confirmed that yet again, but now in more modern times. Thing is that White can also extrapolate that further still with regards relating to the warp drive. Though White's focus and understanding from our perspective, and we haven't had any long conversations with him, but from our perspective, there's still much that he has not taken into consideration. So, well, of course, he can listen to our podcasts and then give us his 2 cents worth if he'd like, and it's welcome if he wishes. But Renee, did you have something more you wanted to add to this?
What you can do is that by effectively going to speed of light with a ordinary warp drive and reducing your mass as you approach the speed of light, you reduce your mass, and you can actually do that using quantum vacuum energy, but that's another topic. As you approach the speed of light, you rapidly drop your mass, your acceleration grows enormously, and if you accelerate enough, you are now moving some distance well beyond the speed of light in a time less than one time quantum, less than one chronon. As a result, you and your entire ship are completely converted to tachyons, which produces the tachyonic warp bubble, which will accelerate exponentially. You shoot off to enormous speed, but then just as you approach the speed of light, how effective mass increases from some points of view. As the amount of elapsed time approaches that of one chronon, the ship will be forced to rematerialize. Space and time will shift and will be forced to rematerialize, now having traveled an enormous distance. And that, practically speaking, is how we'll actually go about and build a jump drive, a discontinuous drive.
So
that's what we'll get the tachyons. And from that you can
go ahead.
From that you can then deduce like how long it might take us to get to this point. For one, we might be able to create a kind of sublight warp drive using these higher order EM radiation in the next 20, 30 years, and maybe sooner in the atmosphere in some form as a kind of MHD, magnetohydrodynamic drive. Yeah. Or, well, magnetohydrodynamic drive in the atmosphere.
Yes.
So, because here's the thing. Neutron stars, their magnetic fields, which are something around the order of 1 million Tesla, actually polarize space itself. So light going through it becomes polarized. Now, if you have it higher order radiation, it'll actually interact and couple with space-time a lot more strongly, which means you need much less field strength. To the point you may only need like a few 100,000 Tesla. And while that seems like a lot, a couple things to consider. A fusion drive can have power outputs in the order, or antimatter drive would have power outputs on the order of terawatts. That's probably going to be more than enough to generate such fields. And new materials like ultra-dense hydrogen can potentially support magnetic fields up to 100,000 Tesla without breaking down.
It is a superconductor.
Yeah.
I think this is really good that we're getting Paul's perspective. Everyone can relate better. And that's the whole idea. So we're talking about all this.
All right, I'm back.
How much are you following so far?
Actually, you guys lost me about 2 minutes ago as far as me understanding what you were saying.
What part? Talking about the chronon?
Yeah, the chronon.
Okay,
do you know how do you spell that? Is it
CHRON.
Oh, like it's
CHRONON.
Okay, cool. I jotted it down that way I could look it up later.
Yeah, the figures you'll find for it are just wild guesses, though.
Oh, okay.
You might find better results if you look up effective Planck constant in higher dimensions, but that's another topic.
Oh, okay.
So I can explain it with an analogy like if you have some game like Elite Dangerous where there's a maximum speed that the game will let you go, right?
Yeah.
You could theoretically cheat past that anyway if you were to. The game has a certain game tick, and like it takes some amount of time for the game to do a full calculation. Hence why you get so many frames per second. If you have some ship in the game that could accelerate fast enough, you could accelerate so that on one game cycle it calculates your position at one spot, and the next one it calculates you some very far distance away based on your acceleration, But to get there in such a short time would be well beyond the speed the game lets you go. But because you've done it so quickly, the game had no time to react, so to speak. Does that make sense?
Yeah, it makes sense.
Or another example is some games you can glitch through walls, because how it works is a game only calculates collision when an object actually intersects with it. So if on one game tick you are not colliding with the wall, and you're moving so fast, and on the very next game tick you're already on the other side of the wall when it computes the new location without any intersection, then the game sees no problem. It doesn't even try to stop you. And just like that, you've teleported through, tunneled through the wall.
Oh.
It's effectively very similar with... It's effectively the same with space-time, with the jump drive. The ship drops its mass when it gets up to, with an ordinary warp drive, to right below the speed of light, drops its mass, and as a result, because if you have something that you're pushing with a certain constant force, and it suddenly were to get lighter, it will accelerate much more quickly. So if you're accelerating even with just a light drive, like just emit a very bright light as your propulsion system, and you drop your mass to very nearly zero, your acceleration will become something extremely high, like absurd practically. And with such a high acceleration, you are moving some distance well beyond the speed, and moving it well beyond the speed of light in less than one time quantum. And if you look at the equation describing the velocity-energy ratio, and you plug in a velocity that's beyond the speed of light, it tells you that the particle is a tachyon. It has a magister. It tells you that the particle has an imaginary rest mass. Or vice versa, if you plug in that mass, it tells you that its speed is beyond the speed of light. That's probably not the best explanation. I can't really explain this properly without going into a lot more detail, but basically it's like this. Anything that exists that does something that takes less than one time quantum, less than one chronon, must be a tachyon for that duration. Does that make sense?
Actually, yeah, that actually made a lot more sense. That right there.
So yeah. What happens by creating such a huge acceleration? The ship is already moving well beyond the speed of light before in much less than one time quantum, and therefore the ship and the space around it must turn into tachyons because it's doing something so fast. That makes sense?
Yeah.
Now, but it can't stay that way, because the way it works out is that anything that exists for longer than so it's kind of like an either-or situation. If it exists or does something for faster than one chronon, it has to be a tachyon. But if it does something for longer than one chronon, it cannot be a tachyon. It's an either-or. So yeah, as the time passes...
Oh, sorry. Yeah, in that point, when you're in that tachyonic state, what is it that you would do to achieve renormalization? Nothing.
It will happen automatically if you set it up correctly. Because as the amount of time you've been traveling for approaches that of a chronon, you cannot stay as a chronon. As a tachyon. And so space-time shifts and you rapidly decelerate on your own. And by the time one chronon has passed, you're now very far away and traveling only the speed of light again.
Oh, okay.
So you are dematerialized when you're between the pixels, so to speak. And during that time, when you're between chronons or between time quanta, you are immaterial and therefore unable to do anything. Your ship doesn't exist. You don't exist as a normal matter. You're just pure energy. You would not be able to look around at your controls and switch it. You can't even have your computer switch anything because it's just pure energy. But due to the nature of normal matter, as Renee is saying, you automatically recondense back into normal matter because that's a fundamental law of how matter and tachyons work. together. You follow? When you're between those pixels, you are effectively negative energy.
Yeah, that makes sense.
You exist everywhere and everywhen. But because you started out as normal matter, when you reach the next quantum of time, boom, you're right back as normal matter. Question? Any questions there?
Oh, no.
Okay.
That makes sense.
Yes. And that's how you come back. That's how you are able to make the jump. But as Renee was saying, what determines where and when you return, rematerialize, is dependent on how you set up the jump prior to jump. Because once you're in between chronons, as existing as negative energy, you can't do anything. You can't even. You're not even aware of your jump, and that's why we say jump drive or discontinuous drive. It's because you are there 1 minute, gone, and then reappear the next unit of time, the next quantum of time. I think we've covered this so far fairly good. Sometimes we have better days, and sometimes we're a little rough around the edges. Did you have something more to say, Paul?
Not at all, except this is a lot of fun, really cool, and I got a lot of notes I wrote down, just having the conversation.
Yeah, as you dive into and start to learn what we're talking about, and of course, within the video description of each video, not so much podcasts, some of the podcasts have links, but within the video description of our videos, we have placed links to papers. Anyone who's looking to learn what we're talking about is one, of course, listen to our podcasts, watch our videos, but also don't just stop at our videos and podcasts. Go to those links, read those papers. Go to Musha's papers, his colleagues, White's. Read everything you can, and eventually you'll begin to discern more and more. You'll be able to understand and comprehend more and more. So for those would-be potential Scotties and engineers and what have you. Now, as far as captains go, well, more like a coordinator. And Renee and I have had a long discussion about this. Yes, there needs to be some degree of control, but we can't do it in a military fashion, in our opinion. This is where Star Trek gets it wrong. But that's a conversation for a whole nother day. Renee, did you have anything more to say?
No, I think that's enough now. I need to.
Yeah, you need to go on. And we are, according to my clock, at the 2-hour mark. So, well, Paul, I want to thank you very much for coming on. And yes,
there is something I do got to say. I'm sorry to interrupt.
No, we interrupt each other because we do. Yeah. Please carry on.
For those of you out there like me that, want to actually get involved in warp drive research, warp drive R&D and stuff, the first phase is just educating yourself to get caught up, to get at the education level you need to be so you can get at it. And I found the AsteronX YouTube channel the perfect channel to do that with. But like any tool, you have to use the tool correctly in order for it to be most effective. And there's something that I did, and I highly recommend you guys do, is that if you're as curious about the science behind FTL propulsion research and development, I highly, highly recommend that you go to the videos tab in the YouTube channel and watch all the videos in chronological order and the dates that they were released, because they kind of build on each other. Kind of like how you don't study algebra without first studying pre-algebra, and it will really help you comprehend a lot of things. And I did it that way, and it worked great. And I highly recommend that for other viewers who are kind of in the same shoes that I'm in.
Excellent. Yes, that's right. As I said a minute ago, don't just rely on our information. Do your research. Learn from everybody. Sure, there's a lot of videos out there that don't quite understand it correctly or don't understand it at all. But you need to go through them all. You need to see them all. You need to learn. Yeah, I guess you can kind of say it's the hard way, but hey, that's the best way. When you can learn something and know it for yourself, and then somebody comes along and tells you what the reality is, then you say, yeah, I know that because I've been there and done that. I've seen both sides. I've seen both camps of thoughts, and here's why I think that this is the correct camp, and then then you are equipped to explain with intelligence why this is the camp that I think, or why this is the correct path. I think that's great advice. Again, don't just rely on our information. Get out there, contact these people if you so see fit to do so. So on that note, Paul, I do have to make sure to ask you this. Do we have your permission to post this on YouTube? Even because we are also going to, of course, monetize it as well to help support the mission, the project. Do we have your permission?
Oh, yeah. Yeah, you do.
Okay. So, fantastic. Then on that note, thank you again, Paul, for being here. Renee, thank you for your contribution.
Yep.
As I always say to everybody, keep wondering about space. Thank you.
Bye.